This is your video for lesson 32.2, solving quadratic equations by completing the square. So take a moment if you would and go through our learning targets. Remember, you're going to annotate, so you're going to circle the verb and underline the noun. Okay, so at any time, of course, you can pause the video, rewind if needed to go back and revisit anything that you might have missed or need to hear again. So we're going to just jump right into this. In the previous lesson, you solved quadratic equations by isolating x squared and then using square roots. This method works if the quadratic equation, when written in standard form, is a perfect square trinomial. If you need to pause for a minute and look up that key term, please do it, because that is pretty significant for us. And it's been a while, so you might have forgotten what that is, of course. When a quadratic is a perfect square, there is a relationship between the coefficient of the x term and the constant term. So here we're talking about our b value and our c value. An expression in the form of x squared plus bx is not a perfect square. However, you can use the relationship shown above, over here, to add terms to x squared plus bx to form a trinomial that is a perfect square. So basically, we can use algebra to manipulate a function, a quadratic function, to make it a perfect square and then solve using this strategy. So remember, we've done several strategies already for solving quadratics. There are 5 total, and we have already solved by factoring, we've already solved by square roots, and we've solved by graphing. So solving by completing the square is our 4th strategy in solving quadratic functions. This is called completing the square. To complete the square of x squared plus bx, add b over 2 squared to the expression, and that will form your perfect square trinomial. So we're going to practice calculating our b over 2 squared first. So looking at number 1, letter A, we're given this quadratic, and we want to know what will we have to make the c value to create this perfect square trinomial. We're going to use this formula b over 2 and then square it. So our b value is 12. We're going to divide it by 2 and then square it. So we have 6 squared, which is 36. So to make this a perfect square trinomial, we would have to put a 36 there. And then we could go on with the steps of completing the square to solve. Letter B, at this time, go ahead and pause the video, see if you could calculate your b over 2 squared. Okay, so in letter B, we're having 2 kind of significant things happening here. First of all, our b value is odd, meaning it's not going to divide by 2 and come out pretty. It's going to come out a fraction, and that's okay. We can work with fractions here. The second thing that we want to be reminded of is that even though it's a negative, whenever you square something, you're multiplying by itself, so it's going to turn back positive. So when you use this method, you're essentially always going to be adding a positive number to your equation. 25 over 4, how I got that is by squaring the numerator and the denominator. All right, when you're ready, go ahead and pause, or go ahead and try letter C. And then here I noticed my b value was 8. They did kind of flip those a and b terms just to kind of try to trick you, so you got to be careful with that. Remember, your b value is always your coefficient to just your x. So 8 over 2 is 4, squared is 16, so I added the 16 there. All right, now we're going to actually talk about the steps to completing the square. Step 1 is to write the equation in the form of ax squared plus bx equals c. Step 2 is to find b over 2 squared, which is what we practiced doing, so that skill will be embedded in our steps, which is why we practiced it. We're going to complete the square by adding that result, that b over 2 squared, to both sides of the equation. Remember, in algebra, to keep it balanced, what you do to one side, you have to do to the other. So if I add that number to one side when I'm solving, I'm going to have to add that number to the other side of the equal sign as well. Step 4. factor the perfect square trinomial. Step 5 is to take the square root of both sides. Step 6 is to write both equations using both the positive and negative square root. Remember, whenever you square root, you have two answers, the positive and negative version of that number. And then step 7 is to solve both equations, or solve each equation. Since you just created two equations, you will have to solve both of them. So a lot of times we will end up with two answers here. Remember, that's okay, because when we're solving quadratics, we're looking for the roots of that quadratic, and a lot of our quadratic functions have two roots or x-intercepts because of the way that the parabola is formed. Ready for task 2 here. We're actually going to start solving a few of these quadratics using the complete the square method. Okay, so here we're ready to start with our steps, and of course you can look back up at your paper to kind of review those steps as needed. The first step is to write our quadratic in the correct format, and so what we noticed from step 1 is that we need our constant on the other side of the equation. So that means I'm going to have to add 5 here to both sides. So we cancel it there, and then that would bring this c value over to that side. The second step is going to be to calculate that b over 2 squared. So my b is 8 over 2 squared gives me what? 4 squared, which is 16. And then my next step is to add that to both sides. So both sides the equal sign. So I'm adding the 16, adding the 16. I end up with t squared minus 8t plus 16 equals 21. Okay, and then now we're going to factor our quadratic, our trinomial here. So it's going to be factored into two binomials. You guys remember how to factor. So t times t gives me my t squared. And then now I need two numbers that when multiplied equal 16, but when added together equal -8. So that would be -4. Because -4 plus -4 is a -8, but -4 times -4 is a positive 16. Now I'm ready to square root both sides. So again, I'm just following these steps. If you need to scroll back up, take the square root of both sides. I'm on step 5. So before I do this step, I want to point out that t minus 4 times t minus 4 is the same as t minus 4 squared. And it's really important to notice that connection, because essentially what's happening when we're square rooting is the square root and the squared here are going to cancel. And what it's going to leave me with, and I'm going to have to come up here, is t minus 4 equals the plus or minus square root of 21. So I'm going to set up and solve my two equations. So t equals, I'm going to add 4 to both sides, which will give me 4. Actually, I don't even need those arrows, because this one's going to be pretty easy. I just add 4 to both sides, plus or minus the square root of 21. So notice the square root of 21 is not a perfect square. If I square root that using my calculator, it's going to come out a messy decimal. It's not going to come out a whole number. So if they don't come out a whole number, we're just going to leave it in radical form, which means you're going to leave the radical in there. So I do have two answers here, 4 plus the square root of 21 and 4 minus the square root of 21. And of course I could go ahead and use my calculator and take those to a rounded decimal if I wanted to, which is just a matter of plugging them into your calculator. But truly the most accurate answer that I could give here is leaving it in radical form. So that's what I'm going to do. At this point, I'd like you to pause the video, maybe start number 4, maybe even on a scratch piece of paper, just so you can kind of see how far you can get. It's really important that you give yourself that opportunity. Even if you get stuck quick, that's okay. That's part of the learning process. Okay, so I'm going to jump in and kind of start this process. Let's see how far you guys got. Luckily, step 1 is already done for us. Our C value is already over here. So our next step would be just calculating that B over 2 squared, which would be 25. So I'm adding the 25 to both sides. So that would give me x squared plus 10x plus 25 equals 25 minus 9 is 16, positive 16. Okay, now I'm ready to factor. So I need 2 binomials. To get x squared, of course, it's x and x. And to get multiplied to get 25, add to be 5, it's going to be 5. Now, guys, these are perfect squares. So what I should be getting inside these binomials is the exact same thing. That's the whole point of this. That's the whole point of finding that b over 2 squared and adding it, tacking it on to both sides of the equation, because that is what creates that perfect square. So when we do factor, we get the same exact thing. We're ready to square root both sides, which is going to leave me with just the x plus 5 equals, the square root of 16 is 4, and the square root of 16 is negative 4. So I'm going to solve both of these equations. I'm going to subtract 5, which would give me a negative 1 here. I'm going to subtract 5, which is going to give me a negative 9 here. So my two answers came out nice, pretty integers, no messy decimals this time, or radical form, and the two answers for that quadratic would be negative 1 and negative 9. All right, let's look at number 5. Like I said before, it's really important that you pause the video, go ahead and try this one on your own, see how far you can get, even if you do it on a separate piece of paper or something. All right, so we're ready to find, it's already in the correct format, so we're ready to calculate our b over 2 squared, which was going to give us 64. So I'm grabbing a different color here. Okay, so I'm going to add that to both sides. I have x squared plus 16x plus 64, and 64 minus 15 gives us 49. I think this one's going to come out pretty like this one because I'm noticing I have some perfect square numbers here that are going to be helpful. So I'm ready to factor. X times x gives me my x squared. Two numbers that when multiplied equals 64, when added together equals 16. It's going to have to be a positive 8. Okay, and now I'm ready to square root both sides, of course, because what I do to one side, I have to do the other. So I end up with x plus 8 equals positive 7, because that's the square root of 49, and x plus 8 equals negative 7. And then I'm ready to solve. So I'm subtracting 8 from both sides. Subtracting 8 over here will give me a negative 15. So here are my two answers, nice pretty integers, no messy radicals or decimals. And that quadratic also has two solutions, 2 zeros, 2 roots, 2 x-intercepts, whatever you want to call them. All right, we are going to go on to task 3. If you need a pause and maybe do some practice on that, you can go ahead and jump to the assignment and do completing the square with some quadratics that have an a value of 1 to keep it simple. If not, just stick with me and we'll go ahead and keep going. All right, so the first step is to get it in the correct format. And the correct format is going to involve getting this negative 2 over to the other side. Actually, I think I can only make up to 15-minute video. So this video is going to have to be in 2 parts. I'm going to go ahead and stop this one, and then I'll jump back in with you on task 3.